Welcome back to the channel. In the last episode, we mastered chain of thought. Today we are going bigger because chain of thought only gives you one reasoning path. But real experts don't stop at one idea. They explore multiple possibilities and evaluate them. That's exactly what tree of thought does. Let's dive in. Before we jump into demos, let me share the research behind thought and explain why it's such a breakthrough. Tree of thoughts, deliberate problem solving with large language models. This is the core paper that introduced tree of thought. It showed that letting models explore multiple thoughts instead of committing to one dramatically boosts accuracy in puzzles, optimization tasks, maths, and reasoning. This diagram shows the evolution of LLM reasoning. This is taken from the research paper we just saw. So let's break it down. On the left, you see the earliest method, input-output prompting. You give an input, the model gives one output. No reasoning, no breakdown. The next is chain of thought. Here the model doesn't just answer, it explains its step. But the catch is it follows only one reasoning path. If that path is wrong, the answer is wrong. Next, we move to self-consistency with COT. Instead of generating one reasoning chain, the model now generates multiple reasoning chains and picks up the most common final answer using a majority vote. Better, but still limited because it's sampling different full chains, not exploring different directions. Now, look at the last diagram. Tree of thoughts. This is where the things get powerful. Instead of committing to single chain, the model branches its reasoning like a tree. At each step, it explores several possible ideas, evaluate them, keeps promising ones, and prune the bad ones. So this allows the model to backtrack, explore alternatives, and eventually choose the best overall solution path. And that's the essence of tree of thought. There are other research papers that I have added in the description of this video. Please go through them. Now let's look at a better breakdown of thought framework. Thought use thought decomposition, which is breaking the problem into smaller ideas. So thought is just a small idea, not a full answer, just one step towards an answer. Humans do this naturally. We break the big problem into smaller decisions. Next one is branching. So thought explore multiple ideas instead of just one. In the normal prompting, the model picks up one reasoning path, which is what we have seen in the chain of thought. In thought, the model behaves like a brainstorming team, generating several possible directions simultaneously. For example, A direction, thought B, thought C, thought D. So you are asking the model to explore. Don't commit until you explore. Next one is state evaluation. It judges which ideas are good or which are bad. So this is the secret sauce. Each idea, each thought is evaluated. The model scores it based on usefulness, correctness, cost, feasibility, or any criteria we define in our prompt. For example, will this solve the problem, or is it logically consistent, or does it align with the instruction? We are literally teaching the model to think about its own thinking. Next one is pruning. This is about removing bad directions and expand on the good ones. So once thoughts are scored, weak ideas are pruned, removed from the search tree, and the strong ideas get expanded into further branches, as you can see in this diagram. Just like humans, so we disregard all the bad ideas and we always explore deeper for the good ones. So this prevents the model from wasting time on the dead ends. Next is search algorithms. This is about different ways of exploring the tree. So these are the search algorithms that thought uses to explore various ways. The first one is breadth first search. So this is to explore many operations shallowly before going deeper. So it goes through these options first before going down the line. For example, you are planning a holiday. You look at all the holiday destinations first. Then you pick one to explore further. That's what breadth first search is. Next one is depth first search, which is pick one idea, go deep into it before exploring others. For example, you choose Bali for your destination. Then you explore flights, hotels, budget, and only then you compare with others. The third one is beam search. Beam search is about keeping only the top n best options at each step. For example, start with 10 destinations and you want to keep the best 3 options and expand only on those. The next one is Monte Carlo tree search. This is simulating many possible paths like AlphaGo, then pick the best. You can see that these search algorithms allow thought mechanism to explore huge decision space intelligently, not randomly. So we now move to the Python code to see this in action. Alright, now let's look at a real working example with a tree of thought in code. In this Python script, I'm using Grok API with Llama 3 model. We will use a realistic cloud problem, which is choose the optimal data ingestion pipeline for streaming 200k events per second into AWS. Let's walk through the code first. So first we import the libraries that we need, Grok and OS. Here I am expecting the API key to come from environment variable, which I have already set up. If it's missing, we raise a clear error. Then I create a Grok client and choose the model that I want to use. You can easily swap this model to whatever you want, but I'm gonna use like this 8 billion instant model. Next is our helper function. This is a small function, a thin wrapper around Grok chat completion API. I pass system prompt and user prompt here, and I'm using a hard-coded value for the temperature to keep the answers focused and deterministic, which is important for architectural decisions. Next is our main function, which is tree of thought. Here I'm telling the model to behave like a principal AWS solution architect and to explicitly use tree of thought reasoning, and then explore multiple solution paths, evaluate them, and choose the best. Then comes my user prompt. Here's the core prompt. Instead of asking for one answer, I'm forcing the model to propose 3 distinct options with the same structure, and for each structure think through pros and cons and give it a score, then explicitly choose a winner, and then finally produce a clear and production ready architecture in the final recommendation section. So in this case, tree has 3 branches. Each branch has internal reasoning with pros and cons, and then a decision node that picks up the best solution. There's also a tiny helper function, which just to make the console output look nicer. In the end, I'm going to call the tree of thought function. Let's run it. Yeah, now you can look at the output that it has produced options with pros, cons, and score. Then in the final selection section, it says based on the scores, I would recommend option 2, which has 9 score, and the other ones has 8.5, and the first one had 8. And it says that it gives some description about option 2, and then it gives the final recommendation with the detail of production ready solution. So that's a practical implementation of tree of thought. We don't change the model weights, we don't change anything, we just change the prompt structure and we ask for reasoning, and one simple function with options, pros, cons, scores, and a final selection is enough to turn a normal LLM into multi-branch decision engine. Now, although thought framework can help LLMs solve problems that require planning and decision making, it may not be the best efficient prompting technique for common NLP tasks. And also, thought is a resource intensive framework, so you should only use it for the complex tasks. Alright, let's wrap this up. Today we went beyond simple prompting. We looked at how tree of thought actually transforms the way AI reasons. Instead of giving one answer, the model explores multiple paths, evaluate them, scores them, prunes the bad directions, and then commits to the best overall solution. You saw exactly how this works in Python, how one prompt can change the linear step-by-step thinking into a real strategic decision making. And this pattern isn't just useful for cloud architecture. You can use thought for planning, debugging, analysis, creative work, research, anything that requires reasoning across multiple possibilities. If you want to level up your prompting and build genuinely intelligent systems, tree of thought is one of the foundational tools to master. In the upcoming video, we are going to cover more advanced techniques. Thanks for watching this, and if you found this useful, make sure you like the video, subscribe to the channel, and hit the bell icon so you don't miss any next deep dive.